Good morning, friends. Today, we'll try to understand the t-test. The t-test is a statistical test that is used to compare the means of the two groups. It is often used in hypothesis testing to determine whether the process or a treatment actually has an effect on the population of interest or whether the two groups are different from one another. So we are taking the variables, that is the independent variable where the groups are two. So if there are more than two groups in an independent variable, then we are using a one-way ANOVA. So if there are only two groups, let us take, for example, the demographic variables like gender. So where we have only two groups, that is male and female, or it could be the location of a respondent, that could be rural or urban. So whenever we have such cases where the independent variable has only two groups, so then we are using the two t-test. So when there are two groups, and then we are trying to understand whether these two tests, we are trying to understand the difference or say the population of interest between the two groups, whether they are different from each other or not. So on that basis, we will try to understand the t-test. So t-test can be of two different types or two different categories, that is one-tailed or two-tailed. So if you only care whether there are two populations are different from each other, we are checking with the two-tailed test. And when we want to know so the mean of one is greater than other or not. So then we are using the one-tailed t-test. So before that, let us try to understand. So what type of t-test should be used? So there are different types of t-test, and according to the situation or according to the say the problem, we are going to select what type of t-test has to be used. So it can be one sample, two sample, and then a or a paired t-test. So if the groups come from one single population, so then we are using a, say, and then measuring before and after experimental test. So then we are using a paired sample t-test. If the groups are coming for two different populations, that is two different spices or two different people from two different cities, then we are comparing with both of them. So then we are using an independent sample t-test. And if there is only one group being compared against one standard value, let us say, for example, the average height of the class is greater than or equal to 5. Then we are using, in such kind of an example, we are using a one sample t-test. So one sample t-test is used with only one variable, and then we have some standard value. And then we are comparing that against some value. So then we are using a one sample t-test. And paired sample t-test is used with the same sample for two different experiments, that is before and after, maybe, or two different groups, and then we are using a paired sample t-test. Independent sample t-tests are used for two different kind of samples. So in such cases, we are using a, say, independent sample t-test. So let us move further and try to understand the independent sample t-test. So one sample t-test can be calculated with this formula manually. So manually, it is t is equal to x bar minus mu whole divided by sigma divided by standard deviation divided by square root of n. So that is used when we are using the one sample t-test. And then how S can be calculated? So S is calculated with the help of the summation of x minus x bar whole square divided by n minus 1. So S is nothing but the standard deviation. And then x bar is the mean of the sample, mu is the assumed mean, and then standard deviation is represented by sigma. So the null hypothesis is H naught is equal to mu is equal to mu naught. So that is, and the alternative hypothesis can be either, if it is one tail test, then it is H1 is to mu, that is greater than mu naught. So H1 is our mu is greater than mu naught, or mu is less than mu naught. So it can be in case of a one tail test. In case of a two tail test, it is mu is not equal to mu naught. So the decision rule says that reject the null hypothesis given the degrees of freedom n minus 1 at the level of significance when one, in case of one tail t-test, so t calculated value is greater than alpha t alpha, or the t table value, or the t calculated is less than minus t alpha. So in case of a one tail test. In case of a two tail test, the t calculated value is greater than t of alpha by 2. So alpha by 2 represents here 2, it is say divided by 2. So alpha is divided by 2 because we are doing a two-tailed test. So 0.05, if it is a level of significance, then it should be divided by 2. That is 0.025 on one side and then 0.025 on the other side. So both put together is alpha is divided by 2. So in this such cases, we are using a table. So with the help of the table, we can also calculate the values. Then There is an example which is given here. A fertilizer mixing machine is said to give 12 kg of nitrate for every 100 kg of fertilizer. So then 10 bags of 100 kg each are examined. The percentage of nitrate so obtained is 11, 14, 13, 12, 13, 12, 13, 14, 11, and then 12. So is there a reason to believe that the machine is defective? So that is the question. So we can understand by this question that it is a two sample t-test. So why it is two-tailed test. So why it is a two-tailed test? Because it can be either greater or it can also be lesser than that. So we are trying to understand whether it is the machine is equal to 100 or not. So equal to 100 is why 100? Why 100 is because it is average. So it is the mu. So mu average is 100 kg of fertilizer. We are comparing that with the samples and we are trying to understand whether it is greater than that or whether it is less than that. So that is what we are trying to understand. So with the given degrees of freedom, so n is equal to 10 here, and degrees of freedom is 9, that is n minus 1. And at alpha level of 0.05, that is 5% level of significance, the t calculated value from this table, we can find out it as 2.262. So at degrees of freedom 9, so here we can see at degrees of freedom 9, and at a significance level of, say, two-tailed test, that is at a significance level of 0.05. So 0.05, we can see here it is, the table value comes at 2.262. So we can see here it is 2.262 is our table value. So then we can calculate this with the calculated value and then compare. So with the help of calculation value, so the t value is 2.262 as we have seen from the table. And at degrees of freedom 9 and at alpha divided by 2 is equal to 2.025. So that is what we have discussed earlier. So now we'll calculate with the help of the calculated value and then try to compare that with the table value. So t is equal to x bar minus mu divided by s divided by square root by n. So that is how we can calculate. So we have seen here the observations and then we have taken the deviation. So deviation from the average, so deviation from the mean, and then we have squared these deviations, that is squared the deviations x minus x bar square, and then the total of this will be our variance, and then square root is our standard deviation. So standard deviation is 1.08. So we have got the standard deviation is 1.08, n is equal to 12, and this is our x bar, that is 12.5, minus mu is our average, so that is 12. So now after this, then we'll get the value of the calculated value as 1.466. So now we are comparing this 1.466 with our table value, that is 2.262. And then we'll take a decision on accepting or rejecting the null hypothesis. So since the t calculated value, that is 1.446 value is less than the critical value of 2.262, then we can say that the null hypothesis is accepted. So we are accepting this null hypothesis since the calculated value is less than the table value. If it have been more than the table value, then we would have rejected the null hypothesis. This is how we are calculating the t-test, one sample t-test. Now let us go for similarly. So hypothesis testing for say two different sample tests, or it is also can be called as independent sample t-test. So in independent sample t-test, we have the formula to calculate, that is x1 bar minus x2 bar. So this is x bar for the first type of sample, and this is x bar for the second type of sample, whole divided by say, standard deviation of first sample, standard deviation of and second sample, and then divided by number of observations of first sample, and then number sample size of the second observation. So t student can be calculated with the help of, and then the decision rule is our null hypothesis is mu1 minus mu2 is equal to 0. Then it means that there is no difference between the two observations. That is what our null hypothesis says. So the difference, that is one sample and second set of sample, the difference is nil. That is d is equal to 0. There is no difference. And the alternate hypothesis says that there is a difference. If it is one sample t-test, it is more than or less than that. If it is two sample t-test, it is can be higher or lesser than that. So that is how we'll try to understand. So with the help of an example, we'll try to look at here. So the mean life of a sample of 10 electric light bulbs was found to be 1456 hours with a standard deviation of 423 hours. And second sample is of 17 bulbs chosen from a different batch, which showed a mean of 1280 hours and then standard deviation of 398 hours. Is there a significant difference between the means of two batches? Now, with a given data, we have x1 bar, that is 1456, and then n is equal to 10, n1 is equal to 10, and then standard deviation is already given, no need to calculate this. So it is 423, and then x bar is 1280, x bar 2 is, and the 398 is our S2, that is standard deviation of the second sample, and that significance level of 0.05 We are trying to check. So this is our hypothesis statement. So this is a two-tailed test. So our hypothesis statement says that mu1 is equal to mu2, and H1, that is alternate hypothesis, says that mu1 is not equal to mu2. So it means that there is no difference between the first and second samples. And then here, first set and second set of samples. Whereas alternate hypothesis says that they are not equal, and then there is a difference between these two samples. Now, with the help of the formula, we have calculated, and then we have the calculated value comes at 1.067. So which says that this is our calculated value, and we compare that with the table value. The table value comes at 2.06. Since we can see here that the calculated value is less than the table value, so we can say that the null hypothesis is accepted. So hence we can conclude that the mean life of electrical pulse of two batches does not have any difference significantly. This means that there is no difference between these two set of variables, or there is no difference between this set of these two samples. And then finally, we have two sample t-test, or it is also called as paired sample t-test. So paired sample t-test, we have a formula, that is t is equal to d bar minus u of d, then divided by, whole divided by a standard deviation divided by square root of n. So here summation of d minus d bar square is equal to divided by n minus 1, that is square root of this. So that can be broken down again into square root of say summation of d squared divided by n minus 1 minus summation of d whole square divided by n into n minus 1. So here our decision rule says that our decision rule of accepting and rejecting the null hypothesis. So the decision rule says that so h naught is equal to say the mu d is equal to 0. It means that again there is no difference here, and then h1 says that either it is greater than 0 or less than 0 in one-tailed t-test, and then in two-tailed test it is not equal to 0, similarly as we have seen for the previous example. So the decision value says that if the calculated value is less than the critical value, the specified level of significance, then the null hypothesis is accepted. If the calculated value is greater than the table value, then the hypothesis is rejected. Now, there is an example which we can see here. So the HRD manager wishes to see that if there is any difference between change in the ability of the trainees after specific training program. The trainees are taken aptitude test before the start of the program and then after the program. So we have two things here. So before and then after, right? So we have before and after. Two sets of samples are there, before and after. So we have two pairs, and then we are trying to compare the results of these two tests. So the score before the training and then the score after the training. So now we'll calculate with the null hypothesis statement says that there is no difference. That is, the difference is 0. And then it says here in the, if since it is a two-tailed test, so our H1, that is alternate hypothesis, says that mu d is not equal to 0. And with the help of the calculations, then we can conclude that, so d is equal to summation of d by n, that is the average. So d is nothing but the difference here, the difference between the two means. Now we can see that from the table we can see these are the list of the trainees, and then here we have the items of before training, and this is after training. These are the values we have got, and we find out the difference, that is d, the difference between the two training scores, and then we have d square. So we are calculating the square of this d, that comes to 25, and then the total of summation of d square is 903. With this value, then if you put this value into the say formula, then we'll get SD. So SD can be calculated by 903 by 8 minus 45 square. So that is the summation of D divided by 9 into 8. So 9 into 8 would be our n into n minus 1. So finally, we'll get the value as 9.21. With that value, standard deviation value, we can calculate the t value. So t value calculated comes to minus 1.63. And then we have to compare this minus 1.63 with the critical value. So the critical value from the table is minus 2.31. So now we can say that the calculated value 1.63 minus 1.63 is more than the table value, that is minus 2.31. So which says that our null hypothesis can be accepted. So since here again we conclude that there is no change in the ability of the trainees after and the before the training. So we can conclude that there is no difference between the scores of the people who have attended the training, that is the scores before the training and after the training does not have any significant difference. Hence, we are accepting the null hypothesis and we say that there is no difference. So this is how we can calculate the paired sample t-test. Thank you for patient listening. We'll continue in the next session.